According to the current National Electrical Code, all metallic water lines entering a building or structure must be bonded to the electrical grounding system within 5 feet of the point of entry. This also includes plastic water lines that contain a metallic grounding conductor. The NEC does not specifically require bonding to the largest water pipe. However, it does require the bonding to be made to a pipe of sufficient size to provide an effective ground path. Based on the code requirements, installing ground rods and bonding to the nearest cold water pipe within 5 feet of the point of entry is correct. However, if the nearest cold water pipe is not the largest pipe entering the building, bonding to a larger pipe may need to be considered for optimal grounding. In general, following correct practices for bonding water lines to the electrical grounding system is important. However, to ensure compliance with the current NEC, bonding to the largest water pipe entering the building should be done if feasible. Grounding and bonding are essential for electrical safety. They create a low impedance path for fault current to return to the source, allowing overcurrent devices like circuit breakers or fuses to quickly trip and clear the fault. Without proper grounding and bonding, fault currents can linger, creating a shock hazard and potentially damaging equipment. Firstly, grounding refers to connecting the electrical system to the earth. This provides a reference point for voltage and helps to stabilize the system. Secondly, bonding involves connecting all metallic parts of the electrical system together to create a common electrical potential. This prevents voltage differences from occurring between different parts of the system, which could create a shock hazard. The NEC provides detailed requirements for grounding and bonding, covering everything from the size and type of grounding conductors to the methods for connecting them. It is important to follow these requirements carefully to ensure a safe and effective electrical system. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. These electrodes are connected to the grounding bus in the electrical panel. The grounding bus is then connected to the neutral conductor, creating a path for fault current to return to the source. Bonding conductors are used to connect all metallic parts of the electrical system together, including metal conduits, metal enclosures, metal water pipes, and metal gas pipes. These bonding conductors are typically made of copper or aluminum and must be sized according to the NEC. The size of the grounding and bonding conductors depends on the size of the service entrance conductors. The NEC provides tables that specify the minimum size of these conductors based on the size of the service entrance conductors. It is important to consult these tables to ensure that the correct size conductors are used. When installing ground rods, it is important to drive them deep enough into the earth to reach moist soil. The NEC requires that ground rods be driven at least 8 feet into the earth. If the soil is rocky or sandy, it may be necessary to drive the ground rods deeper or to use multiple ground rods. When bonding to metal water pipes, it is important to make a good electrical connection. The NEC requires that the bonding conductor be connected to the water pipe using a listed fitting. The fitting must be installed in a way that ensures a reliable electrical connection. It is also important to protect the bonding conductor from corrosion. The NEC requires that the bonding conductor be protected from corrosion by using a suitable coating or by installing it in a conduit. When bonding to metal gas pipes, it is important to follow the gas company's requirements. The gas company may have specific requirements for bonding to gas pipes to prevent corrosion or other problems. It is important to consult with the gas company before bonding to a gas pipe. In addition to the general requirements for grounding and bonding, the NEC also has specific requirements for certain types of equipment. For example, there are specific requirements for grounding and bonding swimming pools, spas, and hot tubs. There are also specific requirements for grounding and bonding electrical equipment in hazardous locations. It is important to consult the NEC to determine the specific requirements for grounding and bonding any type of electrical equipment. Grounding and bonding are complex topics, and it is important to have a thorough understanding of the NEC requirements before installing any electrical equipment. If unsure about any aspect of grounding and bonding, consult with a qualified electrician. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements, you can help to ensure that your electrical system is safe and effective. Remember, electrical work can be dangerous. If you are not qualified to perform electrical work, hire a licensed electrician. Always turn off the power before working on any electrical equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of the potential hazards and take steps to mitigate them. Grounding and bonding are critical components of any electrical system, ensuring safety and proper operation. Grounding provides a path for fault currents to flow back to the source, allowing overcurrent devices to trip and clear the fault. Bonding connects all metal parts of the electrical system together, creating a common electrical potential and preventing voltage differences that could pose a shock hazard. The NEC provides comprehensive guidelines for grounding and bonding, covering various aspects from conductor sizing to electrode installation. The grounding electrode system typically includes ground rods, ground plates, or metal underground water pipes, all connected to the grounding bus and the electrical panel. Bonding conductors connect metal conduits, enclosures, water pipes, and gas pipes, ensuring equipotentiality throughout the system. Selecting the correct size of grounding and bonding conductors is crucial, and the NEC provides tables to determine the minimum size based on the service entrance conductors. Proper installation of ground rods involves driving them deep enough into the earth to reach moist soil, typically at least 8 feet. When bonding to metal water pipes, a listed fitting must be used to ensure a reliable electrical connection, and the bonding conductor should be protected from corrosion. Bonding to metal gas pipes requires adherence to the gas company's specific requirements to prevent any potential hazards. Furthermore, the NEC outlines specific grounding and bonding requirements for specialized equipment such as swimming pools, spas, hot tubs, and electrical equipment in hazardous locations. Compliance with these requirements is essential for ensuring the safety and reliability of the electrical system. When working with electrical systems, always prioritize safety. If unsure about any aspect of grounding and bonding, consulting with a qualified electrician is highly recommended. Adhering to the NEC guidelines and implementing proper grounding and bonding practices can significantly reduce the risk of electrical shock and equipment damage. Grounding and bonding are not just about meeting code requirements, they are about protecting lives and property. A well-grounded and bonded electrical system provides a safe and reliable environment for all users. In addition to the physical connections, regular inspection and maintenance of the grounding and bonding system are essential. This includes checking the integrity of conductors, connections, and electrodes to ensure they are in good working order. Any signs of corrosion or damage should be addressed promptly to maintain the effectiveness of the system. Grounding and bonding are dynamic and evolving fields, with ongoing research and development leading to new technologies and best practices. Staying updated with the latest advancements and code changes is crucial for electrical professionals. Continuous learning and professional development ensure that electricians are equipped with the knowledge and skills necessary to implement the most effective grounding and bonding solutions. Grounding and bonding are not just technical requirements, they are ethical responsibilities. The electrical professionals have a duty to ensure the safety of their clients and the public by adhering to the highest standards of grounding and bonding practices. A commitment to safety and excellence in electrical work is essential for building trust and confidence in the industry. Grounding and bonding are integral to the overall design and performance of an electrical system. They contribute to the stability of the system, reduce electromagnetic interference, and improve the reliability of electronic equipment. A well-designed grounding and bonding system can enhance the performance of sensitive electronic devices and prevent data corruption. Grounding and bonding are also important for protecting against lightning strikes. A properly grounded and bonded electrical system can help to dissipate lightning energy and prevent damage to equipment and structures. Lightning protection systems typically include air terminals, down conductors, and grounding electrodes, all designed to provide a safe path for lightning current to flow to the earth. Grounding and bonding are not just about safety, they are also about sustainability. A well-designed and maintained grounding and bonding system can help to reduce energy consumption and extend the lifespan of electrical equipment. By minimizing voltage fluctuations and preventing equipment damage, grounding and bonding contribute to a more sustainable electrical infrastructure. Grounding and bonding are essential for the integration of renewable energy sources into the electrical grid. Solar panels, wind turbines, and other renewable energy systems must be properly grounded and bonded to ensure their safe and reliable operation. The NEC provides specific requirements for grounding and bonding renewable energy systems. Grounding and bonding are also important for electric vehicles and charging stations. Electric vehicles and charging stations must be properly grounded and bonded to protect against electrical shock and prevent damage to equipment. The NEC provides specific requirements for grounding and bonding electric vehicle charging stations. Grounding and bonding are constantly evolving to meet the challenges of new technologies and applications. As electrical systems become more complex and interconnected, the importance of grounding and bonding will only continue to grow. Staying informed about the latest advancements and best practices is essential for electrical professionals. Grounding and bonding are not just about following rules, they are about understanding the principles behind them. By understanding the principles of grounding and bonding, electricians can make informed decisions and implement effective solutions in a variety of situations. Grounding and bonding are about protecting people, property, and the environment. By adhering to the highest standards of grounding and bonding practices, electricians can contribute to a safer and more sustainable future.